Okay, friends, please submit your attendance in chat box. I am saving your attendance or recording your attendance. Okay, friends, we start today's lecture. Here I am going to share the screen. Okay, friends. Yes, my screen is visible.
Yes, sir.
Okay, thank you, Mahima. Okay, friends, in last lecture we came to here. That is, we put the values of omega 1 and omega 2, that is the ohm minus epsilon and ohm plus epsilon, and from that equation we get this one equation that will be showing with the blue ink. It will be shown in blue ink. This is the one equation, that is the 2a cos of epsilon t cos of ohm t is equal to a epsilon cos of ohm t. And for xb, that is the displacement for the b pendula, and that will be the equation is xb is equal to 2a sine of epsilon t sine of ohm t, that will be equal to b ohm sine of ohm b epsilon sine of ohm t. Just I'm correcting the just my pronunciation. That is xb is equal to 2a sine of epsilon t sine of ohm t is equal to b epsilon sine of ohm t. These two are the equations, and here we are going to see the graphical representation of it. If a weak spring, that is the spring which is connected between two pendula A and B, that is that spring. If a weak spring with small spring constant, that is K, spring constant is indicated by K, and if it is the less, that is the spring having less or weaker spring constant is selected coupling, that is the coupling between two pendula, is the spring is the weak, and that is the spring constant is also less. Then omega 1 is equal to omega 2. If the k constant k is greater, k is very high, then either omega 1 is greater than omega 2 or vice versa. Omega 2 is greater than omega 1. But when the spring having weak coupling, that means the spring constant is very less, then therefore epsilon, that is this is the epsilon is very less than ohm, that is the epsilon is less than ohm. See here, this is the epsilon. Please friend, it is not e, but it is the, this notation is the epsilon, that is this notation is epsilon. Then epsilon is very less than ohm, that is et, that is epsilon is very less, and e into t is the time instant, it will be less. Oscillation is much slower as compared to the ohm t. We know that as ohm is greater, see here I am making this is red, it is shown by the red ink. Both the epsilon and omega will be sent in uh, red ink. Here if epsilon is very less, t is the time instant, et will be slower, means the et will be less than that of the ohm t. Ohm is the, we know that the, it is the for second pendula, that is the B pendula. And then if the epsilon is very less than ohm, then et is less than ohm t. That is ohm t is faster and et is the slower. So farmer simplify the envelope for the latter. That is the farmer म्हणजे पुढचा जो आहे, it is simplifying envelope for the latter. latter साठीचं envelope आपल्याला काय मिळतंय सांगा, farmer मिळतंय. So from equation 1, if we take t is equal to 0, that is time instant, the value of time, or the just the, if we pull the one of the pendulum from other, that is the pendulum A is at the rest and we pull the pendulum B at that instant, if t is 0, t 0, then what about the displacement of the A and B? See clear? See again, what about the displacement of the pendula A and pendula B, that is XA respectively, XA and XB. Then when time instant t is equal to 0, the displacement XA is equal to 2A. That is, it is the amplitude 2A. And what about the XB, which is remaining at the mean position, means its mean position or the equivalent position, equilibrium position does not disturb here, that is the xb is equal to 0. Means that again, please understand very keenly, that is xa is equal to 2a and xb is equal to 0 when that is the instant of the time t is equal to 0. Then its graphical representation, that is the graphical representation of the two displacement, graphical representation of two displacement is how it is. It is like here, just I am showing